Right, so let's go ahead and now take a look at those derived facts. So here we're coming back to our chart, and once again, the facts that are in the white are those that can be derived or figured out from those foundational facts. As you can see, pretty heavy in those 6, 7, 8, 9s, and then in the 3s and 4s, those near foundational facts are something we can keep in mind as we're thinking about what we could use to derive those facts efficiently. So for example, for the fact 6 times 8, I look at that fact and I think, oh wow, 6 is really close to 5. So 5 groups of 8 is 40, so then one more group of 8 would be 48. 5 times 8 is 40, 1 times 8 is 8, and that would be 48. That would be a derived fact. The foundational fact I used was times 5, but really what's happened is I've distributed that 6 into 5 groups of 8 and 1 group of 8. So I use that distributive property. Another example would be the fact 6 times 7. Oftentimes that's a difficult one for students. I know my squares. For whatever reason, 7 times 7 has always been easy for me. 7 times 7 is 49. However, it's 6 times 7, so I actually need one less group of 7, and that would be 42. So in that case, I kind of used what's called compensation. I added on an extra group, but then I adjusted it, and I used the foundational fact of squares. How about the fact 9 times 8? Well, I know my facts of 9 are close to 10, and I'm really good at 10. So 10 times 8 equals 80. But I didn't have 10 groups of 8. I only had 9 groups of 8. So I have to subtract one group of 8 away. 80 minus 8 is 72. Now, you can really see here how you have to be good at those pairs of 10, because when I subtract 8 from 80, that's easy for me because I know that it's 70, and then 2 and 8 is 10. So you can see once again the power of the pairs of 10 and bridging to that 10 decade. Here's another way I could think about 8 by using the distributive property. I have 9 groups of 8, but I'm going to think about that as 5 groups of 8 and 4 groups of 8, which would be 40 and 32. So I distributed that 9 using 5s and 4 because those are familiar and efficient for me. So you can see how if I forgot what 9 times 8 equaled and I sheerly memorized it, then I would be lost if that were the case. But because I have strategies and because I can use other facts and the distributive property, I can figure this fact out. Now, what if I thought about that as 8 times 9 or 8 groups of 9? I could think of it as 4 times 9 and 4 times 9. I used kind of a doubling strategy. I know that doubling 4 is 8, so 4 times 9 and 4 times 9 is 36. 2 groups of 36 is 72. Here's a new fact. 7 times 8 can often be difficult. However, I am pretty good at my multiplying by 5 and multiplying by 2. So I can distribute that 7 into 5 groups of 8 and 2 groups of 8. And then I get 56. If I thought about that fact as 8 times 7, 4 times 7 and 4 times 7, I can double 28, which is 56. Hopefully, those examples just gave you a good idea of what is meant by the derived facts and that thinking out loud in which this is where you want your students to be. You don't want to tell them how they should distribute, but rather you want them to be verbalizing and to show, using different tools and equations, how they could break that fact down into something meaningful. So we are going to go to a tool that is called a partial product finder from the Math Learning Center. I would like to show you how you can really use this tool to help students think about deriving facts. So let's go and make a 6 times 8 array, 6 groups of 8. And here you can see down here it simply says 6 times 8 equals 6 times 8. And we can go ahead and think about how could you distribute or derive 6 times 8 if you did not know it? How could you break it apart? So I can actually do that. So I could think of it as 6 times 4. Do you see 6 groups of 4 in this array? And then 6 times 4. Now you can even look down below and you can see that it shows that related equation. 6 times 4 plus 6 times 4 equals 6 groups of 8. We could also actually think about this in other ways other than just 6 times 4 and 6 times 4. What other ways could we distribute 6 times 8? Perhaps you thought about seeing 3 groups of 8 and 3 groups of 8 to make 6 times 8. Or perhaps you even thought of it as 6 times 5, which is 30, and then 6 times 3. So what's really nice about this is it allows students to visually distribute and derive that fact. So as you are working on these derived facts, this partial product finder can be a really useful tool. Tiles, grid paper, those are useful tools as well.